Hello, today we'll learn the circuit half adder. Now, half adder is a circuit. This is just a block diagram which I have drawn. It is a circuit which takes two binary inputs and it generates two outputs, that is sum and carry. Now here this input A and B are just a single binary bit numbers. Now we have to design the circuit which will do this function. So for that we need a table which includes inputs and outputs. That table is called truth table. So truth table is here. So let me explain this. So as two inputs are there, A and B, the combinations will be 4, naturally 4, 2 raised to 2. Why 2? Because it is a binary and so the base has to be 2. So we are taking 2 raised to 2, 4 combinations. Now what combinations are possible? Both inputs can be 0. Another combination is A is 0, B is 1. Third combination is A is 1, B is 0. And the fourth combination is both inputs will be 1. Now by using binary addition rules, we can write this. If two inputs are 0, the sum will be naturally 0. There is no carry, so carry is also 0. If the next input is 0 and 1, so 0 plus 1, sum will be 1, carry is 0. Third combination, if A is 1, B is 0, naturally 1 plus 0 will be 1, carry is 0 again. Now if two inputs are high, 1 plus 1, then in the binary, as per binary addition rules, if two inputs are high, sum will be 0 and it will generate a carry. So 0 and 1. So this is the truth table of half adder, and we expect we have to do the circuit which will generate this type of data. So now what is required? We have to find out the equation from this truth table. So I will circle the some outputs which are high. So this is high here, this is also high here. So for the SOP equation, that is sum of products equation, I am writing SOP equation for sum will be, you can see here it is 1, that time A is 0 and B is 1. So I can write this as a bar B plus, here sum is high when A is 1 and B is 0, that means it is AB bar. So my SOP equation will be A bar B plus AB bar, and this is nothing but the EXOR gate. We all know that this is the EXOR gate Boolean expression. So we have to use one EXOR gate to generate the sum. Similarly for carry, if you see, it is 1 only once. So what is the equation if I try to write the SOP equation for the carry? SOP equation for carry will be, see here, this is 1, that time A is high, B is also high. So product term will be only single term, and that is AB. And AB is nothing but the AND gate. Therefore, the total diagram for sum and carry will be, it will be a combination of EXOR gate, this is A, this is B, and this is EXOR gate which will generate sum. The same inputs you can tap, and here you can draw AND gate which will generate a carry. So this is the simple circuit of half adder which contains EXOR gate and AND gate. So now this is the theory. Now we have to see whether it's practically correct or no. So we require two ICs which are nothing but EXOR gate IC 7486. You all are aware of all these logic gates. Now inside this 7486 IC there are 4 gates, and one is the 1 and 2 are the inputs of the gate, 3 is the output. Similarly there is another gate. Like this there are 4 gates in this one particular IC. So you can use any one of the gate. So when I have done the hardware connection, I have used this first gate. So my pin numbers will be 1, 2 and 3. Similarly, for the AND gate, I am going to use the IC 7408. That IC inside the construction is like this only. So here also I am using the first gate where inputs are pin number 1, 2 are the inputs and pin number 3 is the output. A, B are the inputs, Y is the output. So now we'll connect the circuit on the breadboard and we'll see how it works. So I have connected the circuit on the breadboard. See, this is the power supply which I am using, which gives me 5 volt. So this on the breadboard, the positive is connected on top over here, negative from this negative is going to on the breadboard I have connected over here. 2 ICs I need. So first IC is 7486, that is EXOR gate, another is 7408, that is AND gate. Now see the connections. Pin number 14 has to be always high, so this is pin number 14 of EXOR, this is pin number 14 of AND gate. Then pin number 7 is to be connected to the ground. See here, 7 has to be connected to the ground. Here also 7 has to be connected to the ground. So see, pin number 7, this green one is connected to the ground. Similarly, this is connected to the ground. Now as per this diagram, as per this circuit diagram, the connections are done. So let me write down the pin numbers over here. This is pin number 1, this is pin number 2, this is pin number 3. Similarly here 1, 2 and 3. So same way these connections are done over here on the breadboard. Here one resistor and LED is connected to show the sum. Here one resistor and LED is connected to show the carry. Now we'll check the output of the circuit. Now I have put it on the supply. Now this is A and this is B. Right now both are high. When they are not connected, when they are open, it acts as 1 1. So as per the truth table, when your inputs are 1 1, your sum should be 0 and your carry should be high. So I could see here my sum LED is off, that means sum is 0 and the carry LED is on. So I actually checked the last step. When it is 1 1, I got the sum 0, I got the carry 1. So we'll test if both the inputs are 0, what will happen. So I am connecting this to 0. I am connecting this A also to the 0. And see, both the LEDs are off. This sum is also off, carry is also off. So my first thing, which this is already tested, I will just make the cross check. Here sum is 0, carry is 0, my both the LEDs are off. So this also I have tested, is coming right. Now we'll check the next combination. A is 0, B is 1. So my B is nothing but this green color. So I will just make it open. I will open it, it acts as a high. So I will open it and you can see here LED, some LED is high and carry LED is 0. Check here, some LED is high, carry LED is 0. So this step is also tested. Now we'll do the next step. A is 1 and B is 0. So what I have to do now? This A is 1, I'll make it open. B has to be grounded. So this B I will connect to the ground. B I will connect to the ground. And see the output. Sum is high, carry is 0. So same way, when 1 and 0, sum is high, carry is 0. So this step is also tested. Last step, let me show you again. If both the output inputs are high, both the inputs are high, my sum is 0 and carry is high. So sum is 0, carry is high. So in this way, this half adder circuit, which we have done the truth table, then we have written the SOP equations. From these SOP equations we got this diagram, then we have mounted it on the breadboard and tested, and it is working fine. This is the way half adder works.